At this point, you may be asking, what is the NASA connection here? One of NASA's main goals is to discover if life exists in other worlds. So what we have to do is we have to form that operational definition of life, and we have to look at life here and compare it to life in other places. For example, if you take a look at the planet Earth, we can look at this place and we can see right off the bat that there is a lot of life going on here. Kids will look at this and they'll say, well, the trees are growing, the sky is blue, there's oxygen that I breathe. One of the things that's probably not quite so obvious to the kids is the question, it could be alive now, but was it once alive? What on this particular planet was once alive? We have to be able to answer that particular question because we want to go to other worlds such as the planet Mars. So if we take a look at Mars, you'll notice that this particular landscape is completely different than the landscape that we saw on Earth. Here you see nothing obviously growing. There's no trees, there's no plants. So the question arises, is there life on this particular planet? We have to go back to our operational definition of life, and we have to start taking soil samples. Again, that's what this project is all about, is taking soil samples, and using those soil samples, we must determine whether life exists or not. We sent a rover there, the Viking, in the mid-70s, 1976, and one of its prime missions was to determine if life existed on this particular planet. So it ran some experiments, the end results being inconclusive. It could not make a determination on whether there was life there at one time or not. It did take a lot of pictures. The pictures were not all that great. They were a little bit grainy, a little bit blurry, but we do have some of that film segment. So let's pause for just a few minutes and take a look at some of that film.
Viking gave us the first view of Mars as if we were standing on the surface. It lasted over 6 years, but never did find conclusive evidence for life on the red planet.
After all, that was the whole purpose of the Viking mission, was to go and land on the surface, scoop up some soil, and see whether or not this planet had developed life. Well, we're still looking for that life, but today we think it's in particular areas. It's not just anywhere on the planet, so we have to be special about where we go to look for it.
Viking did provide a wealth of data. It mapped the entire planet and charted seasonal changes. People began to see the real Mars. Every time we've gone to Mars, we've increased our ability to see details, and we've seen a brand new Mars. But for a Viking, no picture could ever be more powerful than the first one.
Every single time we have gone there, it's been a brand new Mars. But the biggest brand new Mars of all time was in July of 1976.
Let's take a look at another mission to Mars. The Odyssey is a satellite that circled Mars and took pictures of the planet's surface. Now, these pictures were much better than the grainy, blurry pictures that the Viking took. It's actually capable of taking pictures in 3 different modes. It took pictures in visual, it took pictures with gamma rays, and it also took pictures in infrared. These were the better pictures that we got back from Mars. As a matter of fact, I believe that we have some of these pictures in the very next video clip. So let's pause for just a moment and take a look at those.
The camera on Mars Odyssey is called Themis, and it actually is 2 cameras in one. It's a visible light camera, taking pictures like you would see with your eye, and it's also an infrared camera. So we're able to really learn a lot about the composition of the surface, what minerals make up the surface. It's really a powerful tool, and we've created now 2 maps, one in the daytime and one in the nighttime, each of which is the highest resolution global map ever acquired at Mars.
I got interested in Mars when I was a kid. My mom bought me a telescope when I was about 12 years old, and I've been looking at Mars ever since. I was fascinated just because it was this tiny little place a long ways away, and people were trying to speculate what it was like. So all my life I've been trying to take better and better pictures and get closer and closer to help sort of imagine what it would be like to actually walk around on that planet.
We have Odyssey to thank for this next slide. As you can see, we sent another robot to Mars, and it was called the Phoenix. It was a pretty much stationary robot. It went to the North Pole. This particular site was chosen from Odyssey. When Odyssey looked at the North Pole of Mars, it noticed that there was a sheet of ice, or what appeared to be a sheet of ice, underneath the surface. So Phoenix was sent there, and it landed, and it conducted experiments on the surface there. As it dug through, we did notice these white deposits, and scientists were actually able to confirm that there was frozen ice deposits underneath the surface on the North Pole of Mars. After Phoenix, we have another rover that is actually being born as we speak. This is Curiosity. Curiosity is a roving laboratory. It's much bigger than Spirit and Opportunity that are on Mars right now. And it is right now in the Jet Propulsion Laboratory in Pasadena, and it will be launched in the fall of 2011. That leads us into the next video segment. I think we have something on both of these rovers, so let's pause for a moment and take a look.
Phoenix was a Mars lander mission. In 2008, it landed in the North Polar region of Mars. That's about equivalent to Alaska latitude on the Earth, or mid-Greenland. And its job was to land, dig down, and sample the soil and ice that it encountered in that region of Mars.
Mars Science Laboratory will have sophisticated instruments which will be able to look at the mineralogy in much more detail, but also looking at minerals which either were formed by organisms, living organisms, or show signs that living organisms were around when they were formed.
Water is a basic fundamental condition for life to exist. So when we go to Mars and we look for life, we follow the water. Thanks to the Odyssey, the Phoenix, Spirit and Opportunity, we know that Mars does have a supply of water, so we follow the water. Curiosity is going to be doing that for us. When we look for life on Mars, what kind of life are we going to be looking for? Probably not something that resembles you and I. More than likely, we're going to be looking for something that resembles the paramecia or the amoeba that are located right here on Earth. Let's take a look at this next video as it explains to us why water and energy are very important for the creation of life.
Water is a necessary component for life as we know it. So when we think about trying to understand life on other planets, one of our strategies is to understand the water.
We're focusing on Mars because Mars, in its early history, may have been a lot warmer and wetter than it is now.
It looks like there used to be flowing liquid water on the surface of Mars, but today there isn't any liquid water that we can find, or if there is any, it's very infrequent.
We're not looking for aliens. We're not even looking for fossils. We'll be looking for bacteria or signs of bacteria. And the reason for that is because for most of the Earth's history, they have been the predominant form of life. The chances are it may be different from life on Earth, and therefore what we have to look for is it doing the same things that life does on Earth?